Welcome to IOQM 2023 paper. Let's see the part 1 of the video. Okay. In 2023 paper, the pattern is like this. There are 30 questions. 1 to 10 questions carry 2 marks. 11 to 20 carry 3 marks. 21 to 30 carry 5 marks each. Okay. In this one, we will look at 1 to 10 questions. Okay. The 2 marks questions. Let's start. Yeah, the first question is n is a positive integer such that n is between 1 and 1000 inclusive. Let Mn be the number of integers in the set Xn. The Xn set is square root of 4n plus 1, square root of 4n plus 2 up to square root of 4n plus 1000. Basically, 1000 numbers are there in the set. Okay, they're defined as square root of 4n plus I. Okay, I goes from 1 to 1000. Okay, now let A equal to max of Mn. Okay, and B is minimum of Mn. Okay. Okay, so basically in this set you need to find the how many are integers. Okay, how many square roots are really integers. Okay, uh, which means they're perfect squares. Okay, only those numbers, which one has maximum perfect squares, which one has minimum perfect squares. This is what we should check and then find the A minus B, maximum minus minimum. Okay, let's see. For n equal to 1, the x1 is basically square root of 5, square root of 6 up to square root of 1004. Okay, so one thing you remember, in each set x, okay, there are 1000 numbers. Okay, the first set starts from 5 to 1004, square root of. Okay, and how many perfect square roots are there? We know. We can start checking from 5, right? So minimum is 2 square is 4. So 3 square is 9, starts from square root of 9. 4 square is 16, square root of 16, right? So 4. Then like that up to 31. Okay, 32 if you take, it will cross more than 1004. So these are the numbers set, possible set. So M1 is 29. For n equal to 2, okay, same thing. You check again, you will get same set 3 to 31, which is 29. Okay, for n equal to 3, what you will get is 28. Okay, now let's observe what is happening. The window is actually shifting. Okay, here it is from square root of 5 to square root of 1004. Second one is square root of 9 to 1000, square root of 1008. Third one is square root of 13 to square root of 12. Okay, so how the behavior of square of a number. Okay, if you take 1 square and 2 square, the difference is 4 minus 1, which is 3 numbers are there in between, right? Okay, 3 numbers different. But 2 square and 3 square, how many numbers difference is there? 9 minus 4, which is 5 numbers. Okay, so as the window is shifting, you will find less number of perfect square roots. Okay, integer solution for the square root. So as you go, as the window is shifting from 5, 9, 13, next will be like 17, right? The window is shifting to the right, so you will find a less number of square roots. If you know this, obviously the least value will be, highest value will be x1, least will be xn. So for n equal to 1000, the solution set is 4001, square root of 4001, square root of 4002 up to square root of 5000. Here you will find only 64 to 70, that is only 7 values. Okay, so this is the minimum, this is the maximum. So A minus B is, A is 29, B is 7, A minus B is 22. This is the answer. Okay, little bit understanding is required, I would say moderate. Next, find the number of elements in the set A comma B belongs to n natural numbers such that 2 is less than or equal to A comma B less than or equal to 2023. That means A comma B are between 2 and 2023. Okay, and the relation given is log B to the base A plus 6 log A to the base B equal to 5. Okay, so how we will take is, let's take log B to the base A is t. Then the given expression will become t plus, this is 1 by log b to the base a, right? So 6 by t equal to 5. If you simplify, what you will get is t square minus 5t plus 6 equal to 0, which is nothing but t solution is 2 or 3. Okay. So let's take t equal to 2 first, that is log b to the base a equal to 2, which means b equal to a square. Okay. Otherwise, log b to the base a equal to 3, where b equal to a cube. So these are the two number of elements possible in the set. Okay. So a comma b is nothing but a to a square. That means you will get these possible numbers in 2023. 2 to 2023. Okay, 2 comma 4, 3 comma 9, up to 44 comma 1936. 45 if you take, it will cross 2025. Okay, so up to this. Okay, and this is 43 numbers. Okay, 44 minus 2 plus 1, inclusive, both inclusive, so you have to have plus 1. Okay, and then a comma b is a comma a cube. Then these are the values possible, 2 to 12. Okay, so which is nothing but 12 minus 2, 10 plus 1, 11. Okay, so total number of possible elements in the set is 43 plus 11, which is 54. I think this is easy. Next, let alpha comma beta are the positive integers such that 16 by 37 is less than alpha by beta less than 7 by 16. Okay, find all smallest possible values of beta. Okay, so let's take the given expression as 16 by 37 less than alpha by beta less than 7 by 16. Okay, now we are trying to find out for beta, so let's reverse it so that beta will come on the numerator. Okay, 16 by 7 less than beta by alpha less than 37 by 16. Okay, so the value is if I multiply with alpha both sides and then simplify 16 by 7 and 37 by 16, it is 2.28 alpha less than beta less than 2.31 alpha. Okay, now if you see, there is some value of alpha, some multiple basically of this 2.28 and 2.31, right? Where you will have an integer solution possible in between. Okay, now you check the alpha value where integer solution is possible. Okay, so first alpha equal to 1, we know this, there is no integer solution possible for beta. Alpha equal to 2, no. Okay, we have to keep checking. You can also come with you take 1, then 10, then 15, then once it is successful, then come back basically. Okay, so 9, it's not possible. But 10, if you take, yeah, 22.8 to 23.1. So beta is clearly here, you can see 23. Correct? This is a possible solution when alpha is 10. Okay, alpha is 10, beta is 23. So this is the smallest possible value of beta, right? Any other number you take for alpha, beta value will be more. Correct? So this is the smallest possible value. Okay. So this is the final expression alpha and beta. Smallest possible integer is of beta is 23. Okay. This is moderate. Next. Let x comma y be the positive integer such that x power 4 equal to x minus 1 into y cube minus 23 minus 1. Find the maximum possible value of x plus y. Yeah. Let's see. Okay, given expression, subtract 1 from both sides. Why I am doing that? First thing, why 1, why not 2, why not 3, why not 4? Okay, yeah, 4 is also good solution, but why I am doing 1? 1 if I do, this will become x power 4 minus 1, then I can actually factorize it easily. That is why I am doing. Okay, so it will become x power 4 minus 1 equal to x minus 1 into y cube minus 23 minus 1 minus 1, which is minus 2. So if I expand this x power 4 minus 1, it is x minus 1 into x plus 1 into x square plus 1 equal to this expression. Divide with x minus 1 on both sides. It will become x plus 1 into x square plus 1 plus bringing this minus 2 by x minus 1 to the left side equal to 2 by x minus 1 equal to y cube minus 23. Now if you clearly observe it, x is the integer, so x square is the integer, y is the integer. Okay, so this is the integer, x plus 1 is the integer, x square plus 1 is the integer, integer into integer, again you get an integer. Here y cube is integer, integer minus 23, you again get an integer here. So this cannot be a fraction. 2 by x minus 1 cannot be a fraction. Correct? When it is possible? It is possible, okay? It is possible only if x minus 1 is either 1 or 2. Correct? These are the only possible values where you don't get a fraction here. Correct? X minus 1 equal to 1 or 2, which means x equal to 2 or 3. Correct? Okay. Why I cannot take negative values? It is possible that x minus 1 equal to minus 1 minus 2, but it is clearly given x comma y are positive integers. Okay. So I cannot take minus value here. Okay. Even though in that case fraction will become integer, but it will be a negative integer. So I will take only 1 or 2, x equal to 2 or 3. So just substitute two values and check the value. For case 1, x equal to 2, y cube minus 23 equal to 3 into 5 plus 2, which implies y cube equal to 40. So I don't get a integer solution for y in this case. Okay. Next, case 2, x equal to 3. In this case, y cube equal to 64. So I will get a integer solution for y. That is y equal to 4. Okay. So answer is, what's the maximum possible value of x plus 5? 3 plus 4, that is 7. Okay. Easy? Yes. Next. Okay. In a triangle ABC, let's see the diagram and as we read the question. Triangle ABC, okay. E and F are midpoints of AC and AB. Okay, these are midpoints. So obviously FE is parallel to BC because this is midpoint theorem, right? Midpoint joining the midpoint of two sides of triangle is parallel to the third side. Okay. Now the median BE and CF intersect at O. Correct. Okay. BE and CF intersect at O. Okay. P and Q are midpoints of BE and FC. Okay, these are midpoint. P is midpoint of BE, Q is midpoint of FC or CF. Okay, if the area of triangle ABC is 480, find the area of OPQ, this small area, small triangle area. Okay, let's see. Okay, this is given. F comma A are midpoints of AB and AC, so F is parallel to BC, we know it. And if you clearly see this PQ also parallel to BC. Why it is parallel? If you see, uh, this O actually divides BE and FC in a 2:1 ratio. Okay, if this is X, OE is X, then OB is 2X. Out of 2X, this is midpoint actually of BE. So in this triangle, definitely it is a PQ is also parallel to BC. Okay, if PQ is parallel, P comma Q are chosen exactly at midpoints of B and CF. That's why they are parallel basically. Okay. So in OBC and OPQ, OBC and OPQ, okay, what happens? Since BOC, O is same common angle, O, okay, and then P angle is same as B angle here, Q angle is same as C angle here, okay, so they are similar triangles. In a similar triangles, you have a rule, correct? The rule is similar triangles, areas are in the ratio of squares of their sides. Okay. So triangle OPQ area by triangle OBC area equal to OP square by OB square. Okay. Okay. Now let's find out how to get OP and OB values. Okay. And we are trying to find out OPQ, so OBC value also you require. Okay. Triangle FBC, how much this will be? This will be half of ABC because this is F is the midpoint. So this is a median. Median will cut the triangle into equal parts. Correct? So this is half, that is 240. Right? Next. In this triangle, this is 240, right? These two are, okay, BO cuts FC in 2:1 ratio. This is two parts, this is one part. So this triangle areas also of OBC and OBF will be in 2:1 ratio. Okay. So that means that is 2 by 3 of 240, which is nothing but 160. Okay. So OBC is 160. So we got OBC. Now we need is OP by OB. Okay. How much is OP by OB? Okay. If I take OP, P is midpoint of BE. Okay. And OE is 1x, OB is 2x, correct? So obviously if this is midpoint, this is at 1.5x to 1x. So that is 0.5x, correct? So 0.5x by OB. OB is 2x, which is 1 by 4, correct? OP by OB is 1 by 4. So OPQ by OBC equal to OP square by OB. Same equation I'm writing here, which is nothing but 1/16th of 160. OPQ is, that is 10 units. Okay, 10 square units. OPQ. Hope you understand this. Okay, easy. Actually, given the geometry problem, this is easy actually in IOQM. Next.
Let X be the set of all even positive integers, note down even positive integers n such that measure of angle of some regular polygon is n degrees. Find the number of elements in X. Okay. So X is nothing but, okay, if angle of regular polygon of k sides, let's say angle of n is the angle of regular polygon of k sides. Okay. And k has to be greater than or equal to 3. Okay, you cannot form a polygon with one or two sides. Okay. Then what is the angle of a regular polygon? K minus 2 into 180 divided by number of sides, that is k. You will get the angle, so one angle in the polygon, which is equal to n. Okay. And is telling this n is nothing but even positive integers we need to find. Okay. So even positive integer, I will write it as 2p. Okay. So p equal to, what is the p value then? K minus 2 into 180 by 2, which is 90 by k. Okay. If I simplify it further, it is 90 minus, okay, I'm dividing with k, right? 90 minus k, I'm taking inside. So 90 minus 180 by k. Okay. Now just observe carefully. Again, it's all thinking from number theory point of view. We know p is the integer, okay, because 2p is a even number, so p is the integer, positive integer that too. Okay. K is number of sides of polygon, which is again integer. Okay. So if p is integer, LHS side, then 90 minus 180 by k also should be an integer. So here that means k should be factor of 180. Correct? K should be a factor of 180. So how many factors of 180 are there? Okay. So many. Okay. 1, 2, 3, 4, 5, 6 up to like 180 you count. There are total 18. Out of this 18, k cannot be 1 or 2. Because polygon you cannot form with one or two sides. Okay, so you remove these two values. Then total values are, possible k values are 18 minus 2, which is 16. Right? So 16 is the answer. Okay. So here I just want to tell you one small trick actually. To find any given number factors, okay, instead of writing it completely, you may miss. Suppose if this number is very big number, you might miss one or two numbers, right? So your count will go wrong, number of factors, right? So the trick is you write in a prime factor method. Okay. So that is 180. I can write it as 2 square into 3 square into 5. Okay. Then total number of factors is 2 here, power 2, power 2, power 1, right? So 2 plus 1 into 2 plus 1 into 1 plus 1. That is 3 into 3 into 2. That is 18. Okay. So note down this trick. This is very useful actually in many problems. Okay, I think this problem is easy. Just you need to do factors correctly. Okay, next. Okay, there is an unconventional die. are made to be designed such that six faces are marked with numbers from 1 to 6 as normal, but with 1 and 2 are appearing on the opposite faces. Further, each face is colored with either red or yellow color, with opposite side faces always of the same color. Okay. Two dice are considered to have same design if one of them can be rotated to obtain a dice that has the same number of colors on the corresponding faces as the other one. Find the number of distinct dice. Okay, you need to find the distinct dice after putting the numbers as well as colors. Okay, so let's see. This is very easy problem if you know the permutations and combinations actually. 1 and 2 are opposite sides. So remaining 3, 4, 5, 6 only you have freedom. Okay. 3, 4, 5, 6 can be arranged in circular fashion in 4C2. Okay. This is 4C2 ways, that is 3 factorial by 2 factorial. Okay. 3 factorial by 2 factorial. Okay. And then any of the two colors can be painted on the dice in 2 into 2 into 2. Three opposite sides, correct? And two colors each. So each one has option of taking any two colors. So 2 into 2 into 2, that is 8 colors. So total number of combinations is very simple. 3 factorial by 2 into 2 into 2 into 2, which is nothing but 24. 6 into 4, right? 24. Okay, this is the answer. I think if you know permutations and combinations, this is a very easy problem. Next. Given a 2 by 2 tile and 7 dominoes of 2 by 1 tile, okay, domino is nothing but smaller tile. Find the number of ways of tiling, okay, that is cover without leaving gaps and without overlapping of any of the two tiles. A 2 by 7 rectangle using some of these tiles. Okay, so you are given a 2 by 7 space, okay, and you have to fill with either 2 by 2 tile or 2 by 1. How many ways I can do this? There are two cases: fill 2 by 7 with only 2 by 1 dominoes or fill with both. Okay, correct? Yes. So first let's take the case one, only with dominoes. Okay. Um, let's say f of n equal to number of ways a 2 cross n can be filled. Okay. So f of 1 is 2 by 1. How many ways I can fill? Only one way, right? That is, this is one space, so I can fill only in one way, one domino. If I have two spaces, that is, I can put the two dominoes in the vertical fashion or horizontal fashion. Okay, right? This is becoming 2 by 2. Now 2 by 2 I can fill with 2 by 1 how? Vertically or horizontally. Correct? So that is two ways. Okay. Now f of 3 onwards, it is equal to sum of the previous two. Why? F of 3, I am adding just one more extra domino, right? Vertical I will fill. But how many number of ways I can fill the previous ones? That I have to count, right? Yes. So that way it will become a recursive function or kind of Fibonacci. F of n equal to f of n minus 1 plus f of n minus 2. Okay. So this way f of 7 is basically 7 tiles I have to fill, right? 2 by 7. So 1, 2, then 2 plus 1, 2 plus 3, 3 plus 5, 5 plus 8, 8 plus 13. So 7 is basically f of 7 is 21. 21 base I can fill. This is case 1. Now case 2 is easier actually. First, let's say you put the 2 by 2 tile here, only one way. So only I am left with only 5 slots of for the dominoes basically. These 5 slots I can fill in f of 5 ways, correct? So first one is f of 5 ways. Now I can put the 2 by 2 in the second slot, second and third slots basically. So I am left with one 2 by 1 on the first side and 4 on the right side, left and right, right? So that can be filled in f of 1 way, f of 4 ways. Okay, similarly, as I shift it, this number will become f of 2 into f of 3, f of 3 into f of 2, f of 4 into f of 1, then f of 5. Okay, which is equal to 8 plus 5 plus 6 plus 6 plus 5 plus 8, which is 38. So I can fill this in 38 ways. Total number of ways is 21 plus 38, that is 59. Okay, hope you understand this. It's a medium, yes. Next, find the number of uh, triples ABC of positive integers such that AB is a prime, BC is product of two primes, ABC is not divisible by the square of any prime, and ABC is less than or equal to 30. Okay, let's see. AB is a prime, so either A equal to 1 or B equal to 1. Correct? Because AB should be prime, right? So let's take case 1. A equal to 1 and B is a prime. Okay. Now BC is a product of primes, so that means C also should be prime. BC equal to prime into prime. Now ABC is not divisible by square of any prime. That means B and C cannot be same primes. Correct? If they are same primes, same number 2 into 2, then it is divisible by 2 square, right? That is not possible. So B and C are distinct primes and ABC is less than or equal to 30. So how many combinations possible? Very simple. A is always 1 in this case. So you take 2 comma 3 and distinct. So up to you will get is 13 comma 2 you will get. Okay, 13 comma 2 or 2 comma 13, whatever way you can put, you will get so many. Okay. So B and C positions can be changed also. 2 comma 3 here, 3 comma 2 here, right? So that way. In total 14 combinations if A equal to 1. Now second case is if B equal to 1, then A is a prime because AB is a prime and B is 1, right? So BC is product of primes, which means C has to be prime into prime. Then only you will get a product of primes because B is 1. Okay. And A comma C are made from distinct primes. Otherwise, you can divide them, right? It is not divisible, is it? So A comma C will have basically two primes. Product of two primes is different from A. So it should be distinct primes you should take. Okay, so A comma B comma C are B is always 1. If you take 2 here, you can take only 3 comma 5 here. No other possibility. Okay, if you take 3 here, you have 2 comma 5. Okay, 2 comma 7 also not possible. Okay, 2 comma 7 is 14. 14 into 3 is crossing 30, right? If you take A as 5, then you have only 2 into 3 option. 6 that is. So only 3 options here are possible. 3 combinations. So total combinations are 14 plus 3, that is 17. Okay, this is medium. The next question is there is a sequence A of an, okay, where n is greater than or equal to 0 is defined by a0 equal to 1, a1 equal to minus 4 and an plus 2 is defined as minus 4 an plus 1 minus 7 an. Okay, this is basically an plus 2 is derived from previous two numbers an plus 1 and an. Okay, for n greater than or equal to 0. Find the number of positive integer divisors of expression a50 square minus a49 into a51. Okay, so let's see. A0, A1 are given and expression for next an is given. So let's derive a few numbers first. Okay, an plus 2 equal to minus 4 an plus 1 minus 7 an. So if you substitute the values, a2 you will get 9. Okay, a3 you will get minus 8. a4 you will get minus 31. Okay, now let's see the expression which we need to find out the value. Let's call it a Tn and generalize it. So it is nothing but an square minus an minus 1 into an plus 1. Okay. So let's see for 0, 1, 2, what is the values. Okay. Let's see T of 1. T of 1 is nothing but a1 square minus a0 into a2. Correct. If you substitute the values, you will get 7. Okay. T2. Okay. T2 is a2 square minus a1 into a3. Okay. Which is nothing but 49, that is 7 square. Okay. T3, you can check, you will get 343, that is 7 cube. Okay. So if you see the pattern, it's very clear. Tn is basically 7 power n. Correct? Tn is 7 power n. So what we need is basically T50. Given expression is T50. So T50 equal to 7 power 50, which means product of 57. 7 is a prime. So you cannot have further divisors. So 50 numbers and then 1 plus into 1 you can do, right? So total 51 divisors are there for 7 power 50. Okay. So number of positive divisors equal to 51. I hope you understand this. This problem is hard only mainly because you need to look at the final expression and derive. There is a sequencing basically. Okay. Normally we try to do the rest of the problem, but we don't look at it the given expression and generalize it and do. So this is a difficulty. Okay, this is what is hard. Okay. Yeah, thank you. So we covered all 2 marks questions, 10 2 marks questions. We'll cover the next video, we'll cover the other questions in parts. Okay. This is not as complex as previous, that is 2022 paper at least, I feel. This looks moderately easier compared to 2022. Thank you.